In the previous video, we discussed up to here. Now we are going to discuss about the classification of embedded systems based on these four parameters. The first one is based on generation. The second one is based on complexity and performance requirements. Third one based on deterministic behavior, and fourth one based on triggering. Now, based on generation. So we have four different types of generations. Okay. First generation, second generation, third generation, and fourth generation. Okay. So the first generation of embedded systems are, we call it as early embedded systems built around using 8-bit microprocessors like 8085 and Z80 and 4-bit microcontroller. So that means these embedded systems built around the 8-bit processor controllers. Next, second one, second generation. So the embedded systems which built around the 16-bit microprocessor, 16-bit microcontrollers, following the first generation of embedded systems. So these are called second generation embedded systems. Third one, third generation. So the embedded systems built around high performance 16 or 32-bit microprocessor controllers. So these are coming under third generation, like ASICs, application specific instruction processors, digital signal processors, and application specific integrated circuits. And the last one, fourth generation, the embedded systems built around using SoC, system on chips, reconfigurable processors, and multi-core processors. Multi-core means which is having more than, the processor is having more than one core. So this is about the classification based on this generation. Second one, the classification based on complexity and performance. Okay, so based on the complexity and performance of the system, so we can classify it into three different types. Okay, small scale, medium scale, large scale. Okay, first one, small scale. The early embedded systems built around 8-bit process like 8085. So these are called small scale. Medium scale, like the embedded systems which are built around the 16-bit process, and 8-bit are 16-bit microcontrollers following the first generation. So these are called medium scale. Like large scale are complex embedded systems built around high performance 16 or 32-bit microprocessor controllers like ASICs and DSPs, digital signal processors, and application specific integrated circuits. So these are coming under large scale or complex. Next, major application areas of embedded system. So where do we have already discussed what is an embedded system. So what is the difference between the general purpose embedded system, a general purpose system, and an embedded system, and what are the, how do we classify the embedded system? Okay, as of now we discussed these points. Now we are going to discuss what are the major application areas. Where do we use the embedded systems? So first one is consumer electronics. Second one, household appliances. Third one, home automation and security systems. Fourth one, automotive industry, telecom, computer peripherals, computer networking systems, healthcare, measurement and instrumentation, banking and retail, card readers. Like I'll tell one example here. Consumer electronics means in cameras we can use the embedded systems, like household, like television, DVD players, washing machine. So washing machine is an embedded system, so which is going to perform a specific task or any function that is nothing but washing and drying of clothes. Okay. In microwave oven, which is used for heating purpose, any system which performs a specific task, that is called an embedded system, which is a combination of both hardware and software. Like air conditioners, sprinklers, intruder detection alarm, closed CCTVs, closed circuit televisions, ABS, anti-lock braking systems in the automotive industry, engine control, ignition, any system. Okay, so telecom, like telephone switches, handset, multimedia application, even the mobile phone is called an embedded system. But you have one doubt, sir. Why is it called an embedded system? Because the mobile phone is going to perform various functions like gaming or for listening music like that. Even though it's an multi-purpose system, but there is a high priority task. There is an high priority task that is called calling. Okay, so that's why it's an embedded system which uses the real-time operating system. Like in healthcare, we can use the different kinds of scanners like ECG. EEG is for brain and ECG is for heart. Okay. Banking and retail, ATM, automatic teller machines, currency counters, point of sales, POS terminals, like barcode and smart card readers, any handheld device. So these are all the major application areas of an embedded system. Next, purpose. What is the purpose of an embedded system? So each embedded system is designed to serve the purpose of the combination of these tasks. First one is the data collection or storage or representation. Second one, data communication. Third one, data or signal processing. Fourth one, monitoring. Fifth one, control. And sixth one, application specific user interface. So these are the 6 different purposes of the embedded system. Now we will discuss these purposes in the next video session. Thank you for listening.